start off. So it's been a long time, since we have last met. So let me share my screen. Just let me know even if the audio, you're able to hear. So in we are actually, entering a new chapter, which is thermodynamics. So anybody, can you give me an insight about thermodynamics? According to you, நீங்க என்ன feel பண்றீங்க? What do you understand by the term thermodynamics in your own words? Yes.
It's a study of heat.
Transfer of heat.
Study of heat. Okay, transfer of heat. Very good. That's correct. Thermo abdina, it is basically heat, and dynamics abdina, it is movement. So other than meaning. So if you try to collaborate, you get the meaning of the chapter that thermodynamics is nothing but the study of transfer of heat. That's correct. Okay, so other than meaning பார்க்க போறோம். So moving ahead without any further delay, audio enable பண்ணிருக்கேன், but anyways ஒரு வாட்டி check பண்ணிக்கோங்க. So ensure that your microphones are well connected, volumes are also raised. Okay, so we are moving on to the new chapter, thermodynamics today. So let me start.
Heat and thermal energy. The branch of physics dealing with the study of heat and thermal energy is known as thermodynamics. Although we often think of them as being rather similar, perhaps even using them interchangeably, heat, thermal energy, and temperature are different concepts.
Okay, so is it audible? I hope everybody is able to hear.
Audible,
Yes,
sir.
sir.
Okay, great.
Heat is a measure of the thermal energy that is transferred from one substance to another. To fully understand the concept of heat, we also need to understand temperature. Temperature.
So என்ன சொல்றாங்க அப்படின்னு பாத்தீங்கன்னா, so till now நம்ம என்ன பார்த்தோமோ இந்த animation slideல, so that I'm talking about heat versus the thermal energy. So heat அப்படிங்கிறது என்னன்னு பாத்தீங்கன்னா, the thermal energy that is being transferred from one area to another. So for example, நீங்க ஒரு beaker எடுத்துட்டு நீங்க ஹீட் பண்ணீங்க அப்படின்னா, ஒரு tripod stand மேல வச்சு you are trying to heat it using a Bunsen burner. So the first and foremost part which is going to get heated would be the base of the Bunsen burner. Yeah, the base part. So when it gets heated up, and next the water, very close to the base at the bottom will get heated up first. Adukaprom, obviously, the molecules or heat wave will create agum. So, and because of the heat wave, இங்க என்ன பாத்தீங்கன்னா the தண்ணி வந்து slowly it starts heating up due to the molecules of water getting heated up. The molecules when they get heated up, what happens to the density? They become lighter. So and the molecules வந்து மேல போக ஆரம்பிக்கும், and the ones which are more denser, cold water molecules will come down. So அந்த மாதிரி there is a water current that is set up. அதனால தான் நம்ம சொல்றோம் the kinetic energy of molecules of the substance. இது வந்து நம்ம previous chapterல கூட பார்த்தோம், thermal properties of matterல. So if you can recall, so when molecules get heated up, what happens? They tend to vibrate and they start moving. So உங்களுக்கு நம்ம எல்லாருக்குமே தெரியும், when objects start moving, the energy that they possess, water as a whole, நமக்கு நிறைய water molecules இருக்கும். So we take the average kinetic energy of all the water molecules. So that is what they are trying to elaborate here. So when you talk about temperature அப்படிங்கிறது வந்து it is a measurable quantity. So the measurement of this average kinetic energy of molecules in the substance when a substance is being heated, நீங்க அந்த substance heat பண்றதுனால அந்த substanceல இருக்கக்கூடிய எல்லா moleculesமே they get heated up and they start moving with kinetic energy. So அதோட average நீங்க கண்டுபிடிச்சு நீங்க மெஷர் பண்ண முடிஞ்சது அப்படின்னா நம்ம அந்த temperature அப்படின்னு சொல்றோம். So this is a broad idea about temperature. ஓகேங்களா? So we'll move ahead.
Temperature is the measure of the average kinetic energy of molecules in a substance. And thermal energy is the energy that comes from heat. It's the energy of moving molecules within a substance. The Zeroth Law of Thermodynamics states that when two objects are separately in equilibrium with a third object, they will also be in equilibrium with one another. This will be a state of thermal equilibrium. While reaching this state, heat, flowing as energy, is transferred between the objects. Grab a mug of coffee, which is at a temperature of 80 degrees Celsius or 176 degrees Fahrenheit. Fill a bucket with water that is only 10 degrees Celsius or 50 degrees Fahrenheit. When compared to the water in the bucket, the cup of coffee is hotter. However, the thermal energy of the water in the bucket will be more than the thermal energy of the coffee because of its higher mass.
So you here with respect to thermal energy, you also look at the quantity. So quantity is a very important parameter that we use to understand the thermal energy. So எவ்வளவு quantity இருக்கு கப்ல பாத்தீங்கன்னா P வந்து கம்மியா தான் இருந்தது, but bucket of water எடுத்துக்கிட்டீங்கன்னா obviously there is 3 or 5 gallons of water. So அதனால based on the quantity, obviously thermal energy of water in the bucket is more. நமக்கு தெரியும் கப் ஆஃப் டீல இருந்து வேப்பர்ஸ் வந்துட்டு இருந்துச்சு, ஸோ அது ஹாட்டா இருக்கணும் நீங்க கிளைம் பண்ணலாம். பட் ஸ்டில் why do we say thermal energy of the bucket water in the bucket was higher? Anybody? ஏன் thermal energy வந்து பக்கெட்டுக்கு ஹையா இருக்கு அப்படின்னு சொல்றோம்? What is the prime reason behind it? Even though the cup of tea is less in quantity.
Mass அதிகமா இருந்தனால
more volumes, more quantity.
Yes, it has a greater volume. Obviously, yeah, more quantity. So, abdina, there is more molecules of water present in the bucket. So, when greater molecules are there, a great amount of heat you will have to supply to heat it. So, அதனாலவே நம்ம வந்து பக்கெட்ல இருக்கக்கூடிய தண்ணி வந்து அதுக்கு thermal energy அதிகமா இருக்கும் அப்படின்னு சொல்றோம் than the cup of tea. So, அதுதான் வந்து இங்க ஒரு difference. So, based on the quantity also, the thermal energy will vary. So, greater the quantity, greater would be the thermal energy required to heat up the entire substance, the entire volume of water in the bucket. So, that is the concept. Okay, so we'll move ahead.
Now let's use two identical buckets, one only having 5 gallons of water and the other having 10 gallons. Initially, the water in each bucket will be the same temperature, 10 degrees Celsius. If we were to raise the temperatures equally to 50 degrees Celsius, the bucket with 5 gallons of water will reach the target temperature more quickly. Although the bucket having 10 gallons will have more thermal energy than the first. From the
So அதே கான்செப்ட் தான் இங்கேயும். So even though you நம்ம வந்து identical buckets யூஸ் பண்ணாலுமே, so the bucket having more water takes more time. So அதே லாஜிக் தான் இங்கேயும்.
These examples, we can see that thermal energy is an inherent property of matter, and for it to be changed, we must either apply heat or remove it from a warm body.
So thermal energy பத்தி நம்ம ஸ்டடி பண்ணணும் அப்படின்னா what we'll have to do, we'll have to supply heat from it or we will have to remove the heat. அப்போதான் we understand what is the thermal energy of a particular substance. So by supplying heat, if you're able to heat it successfully to a certain temperature in a shorter amount of time, then we say the thermal energy is less. But even நம்ம heat supply பண்ணியும் அது ரொம்ப குயிக்கா ஹீட் ஆகாம if it is taking more time அப்படின்னா then you would say the thermal energy is typically going to be higher. So higher and lesser is basically based on the, again, you talk about volume, you talk about mass. So adellame you keep in mind whenever you talk about the thermal energy. So that is the idea. So now we move on to the next animation.
The Zeroth Law of Thermodynamics. The Zeroth Law of Thermodynamics states that if two systems or objects are in thermodynamic equilibrium with a third system or object, the two systems are in thermal equilibrium with each other. A British physicist, Ralph H. Equilibrium with each other.
So இங்க என்ன சொல்றாங்கன்னா, this is a statement. So as per Zeroth Law of Thermodynamics. So according to the statement, they are telling that when two objects are in equilibrium with each other. So ரெண்டு block initially எடுத்துக்கிட்டாங்க and they said that those two objects are in thermodynamic equilibrium. What do you mean by a thermodynamic equilibrium? So both of them are at the same temperature. Okay, that is the thermodynamic equilibrium. So அதை நம்ம எடுத்துட்டு போய் when you combine with the third system, you call the third system as C. So அப்போ என்னன்னா A plus B would be equal to C. Those two, first two systems, that is the first system together, when you combine with the third system, மூணாவது system ஓட நம்ம combine பண்ணும்போது, then you say that the combination of both the systems would be in thermal equilibrium with each other. They will attain the same temperature after some time. So that is the meaning. So that is what is zeroth law of thermodynamics. So ஒரு ரெண்டு சிஸ்டம் எடுத்துக்கிறோம், அந்த ரெண்டு சிஸ்டமே thermodynamic equilibrium இருக்குன்னு சொல்றோம், அந்த ரெண்டு பிளாக்குமே ஒரே டெம்பரேச்சர்ல இருக்குன்னு நம்ம சொல்றோம். That is the basic idea. அப்போ அதை கொண்டு போய் நம்ம இன்னொரு பிளாக்கோட சேர்த்து வைக்கும்போது, ஸோ அந்த தேர்ட் பிளாக் கூட அதே ஒரு டெம்பரேச்சர் வந்து மெயின்டைன், இட் வில் பி த சேம் டெம்பரேச்சர் ஆஸ் த ஃபர்ஸ்ட் டூ பிளாக்ஸ். அப்படி இல்லைன்னா நமக்கு எல்லாருக்குமே தெரியும் ஹீட் வில் ஸ்டார்ட் டிரான்ஸ்ஃபர். ஹீட் டிரான்ஸ்ஃபர் வந்து இனிஷியேட் ஆகும் ஃப்ரம் அ ரீஜன் ஆஃப் ஹையர் டு த ரீஜன் ஆஃப் லோவர் heat gradient. So the heat would get transferred from A plus B towards C, and in the heat transfer எது வரையிலுமே நடக்கும், it will keep continuing until the third system also is in equilibrium with the first two systems. So அது வரைக்கும் there will be a heat transfer. So then they will attain thermal equilibrium. So that is what is the main idea of zeroth law. So when you take two systems or objects which is with same temperature and combine it with a third object, then all the three objects or all the three systems would be in thermal equilibrium with each other. Or the two systems combined together would be in thermal equilibrium with each other. So this is what is zeroth law of thermodynamics. Okay, so we'll...
Sir.
Yeah.
Sir, thermal equilibrium thermodynamic equilibrium ஒண்ணுதானே சார்?
Yes, same தான். Okay, so thermal equilibrium and thermodynamic equilibrium ரெண்டுமே same. It is the same meaning only. Okay, so this is what is the idea. நம்ம பாப்போம், we'll see some
The two
questions.
systems are in thermal equilibrium with each other. A British physicist, Ralph H. Fowler, coined the zeroth law as he thought the law was more fundamental than the other laws.
So when நம்ம இப்போ ரெண்டு சிஸ்டமும் thermodynamic equilibrium இருக்கு அப்படின்னு சொல்றோம்னா நம்ம என்ன சொல்ல வரோம், அதுல இருந்து நம்ம என்ன புரிஞ்சுக்கிறோம் அப்படின்னா, we try to understand that the two systems A அப்புறம் B ன்னு எடுத்துக்கலாம். ஃபார் எக்ஸாம்பிள் ரெண்டு சிஸ்டம் A and B, இல்லைனா X and Y எது வேணா எடுத்துக்கலாம். அப்போ when they are in thermal equilibrium, the meaning is both the systems have same temperature. The temperature of both at any particular time would be same. So how do I verify that? We can use a thermometer or you can use a thermostat. You can use it and you can find out. So ரெண்டுமே same temperature இருக்கும். So then you say that they are in thermodynamic equilibrium. அப்படி இல்லைன்னா thermal equilibrium ரெண்டுமே இருக்கு அப்படின்னு சொல்லி we can come to a conclusion. So that is the meaning of thermal equilibrium. So we'll proceed further.
Let's explain this concept. Let's consider a metal block A with a temperature of 20 degrees Celsius and another block C with a temperature of 40 degrees Celsius. Let's move them closer so that they are in physical contact with each other. Heat from the hotter block C will gradually dissipate and increase the temperature of the less hot block A. At one point, both the blocks will be at the same temperature of 30 degrees Celsius, meaning
புரிஞ்சுதுங்களா எதுக்கு ஹீட் ட்ரான்ஸ்ஃபர் எங்க இருந்து எங்க நடக்குது அப்படின்னு? So we already saw this. So you know that heat would get transferred from a hotter body to a colder body. So with respect to C, A was colder. ஏன்னா A ஓட initial temperature வந்து C விட கம்மியா இருந்தது. So when I joined C with A, ரெண்டுமே நான் join பண்றேன். So we understand that they are both in contact with each other and heat would get transferred from C to A. So C ல இருந்து heat is getting transferred to A. So A ஓட initial temperature வந்து முன்ன இருந்ததை விட 10 degrees இப்போ அதிகமா இருக்கு. So இதுக்கு முன்னாடி 20 இருந்தது. Now it has become 30. அது ஏன்னா நான் C வந்து A ஓட I have attached. So attach பண்ணி வச்சதுனால it has increased because the initial temperature of C was greater than that of A, and gradually heat transfer has occurred from C to A. Therefore, the initial temperature of A is now slightly increased by a factor of 10 degrees Celsius. So this is what we understand. So when I combine these two blocks, now don't you think achieved thermal equilibrium? Yes, they have, because
Yes.
both the blocks have the same temperature. So this is the idea of thermal equilibrium. Okay, so I hope you guys understand. So we'll proceed further.
They have achieved thermal equilibrium. Let's consider a third metal block, B, with a temperature of 40 degrees Celsius. When we move the block B to be in contact with the block C, heat exchange will take place between both the blocks until both reach a thermal equilibrium of 35 degrees Celsius. Since block A is also in contact with block C, both blocks will be at the same temperature of 35 degrees Celsius. We can see that the blocks A and B will have same temperatures. This demonstration implies that system A is in thermal equilibrium with system C, and system B is also in thermal equilibrium with system C. So, system A and system B are in thermal equilibrium with each other. One application of the zeroth law is measuring temperature. In thermometers, as the thermal equilibrium is achieved, the mercury will rise to measure the temperature.
So I hope we put the number thermodynamic equilibrium, concept of thermodynamic equilibrium, and the zeroth law of thermodynamics. So any doubts in this module, you can ask me. Other doubts in the you can ask. Otherwise, we'll more proceed for the further concept. This is clear?
Yes, sir.
Yes, no. Okay, great. So we'll now move on. So this is the basic idea. So நம்ம வந்து heat transfer பத்தி பார்த்தோம், thermodynamic equilibrium பத்தி பார்த்திருந்தோம், and we also saw an application of zeroth law of thermodynamics. So according to zeroth law of thermodynamics, now I would like one of you to tell me what is the statement in your own words, உங்க own words நீங்க சொல்லலாம். What do you mean by zeroth law of thermodynamics? Yes, who can come forward and give me the answer?
If two systems are separately in thermal equilibrium, then it tends to be thermal equilibrium with the third one.
With the third system, provided that they are in contact with each other. Yeah. Yes. Okay. Good. So we'll move on. Next part. So next one, then first law of thermodynamics பார்க்கலாம். So moving on to the next module.
First law of thermodynamics. How do we keep ourselves warm on a chilly day? If there is a bonfire, we bring our hands closer to the bonfire. If there is no bonfire, we could simply rub our hands together.
ஸோ இங்கே என்ன சொல்கிறாங்கன்னா, ஒரு சுச்சுவேஷன், சிம்பிள் சுச்சுவேஷன், எல்லாருமே இந்த ஃபயரை சுற்றி உட்காந்துருக்காங்க. இதை வந்து பான் ஃபயர்னு சொல்லுவாங்க டிப்பிக்கலி. ஸோ இப்போ கோல்டர், இப்போ கொடைக்கானல், ஊட்டி எல்லாம் போயிருந்தோம்னா ஏர்லி மார்னிங், ஸோ இந்த கேம்பிங் பண்ணுறவங்க எல்லாம் கேம்ப் ஃபயர்னு சொல்லுவாங்க. ஸோ அதர்வைஸ் வி ஜஸ்ட் ஹேவ் அ பான் ஃபயர். ஸோ ஈவன் ஃபார் போகி ஆல்சோ வி ஹேவ் அ செரிமனி ஆர் ஃபெஸ்டிவிட்டி வேர் ஒரு ஃபயரை வந்து நம்ம வி யூஸ் டு வில் ஜஸ்ட் லைட் இட் அப் இன் ஃப்ரண்ட் ஆஃப் அவர் ஹோம்ஸ். ஸோ இதுல இருந்து நம்ம என்ன what we typically get from this fire is basically the heat. Yeah, so in colder countries typically people have a tendency to have this bonfire kind of a setup, and எல்லாருமே வந்து அதை சுத்தி உட்காந்துக்குவாங்க, and we would like to enjoy the heat in the cold climatic conditions. So நம்ம பாடி டெம்பரேச்சர்ஸை வந்து ரொம்ப கூல் ஆகாம அது வந்து மிதமான ஒரு டெம்பரேச்சர்ல வந்து மெயின்டைன் பண்றதுக்கு we do this. So this is heat அப்படிங்கிறது என்ன? Is it same as temperature? இல்ல is it different from temperature? So ரெண்டுமே சேமா, heat and temperature, or is it different? Yes.
So heat is a property, but temperature is temperature is which measure the heat, sir.
Temperature
Heat
is
is a measure of temperature.
correct. Heat வந்து is a measure of temperature. Okay. Anybody else? Same thing only. Heat to temperature में ரெண்டுமே interconnected terms தான். They have a different meaning when you try to understand this concepts of heat. Heat அப்படிங்கிறது வந்து purely energy தான். ஏன்னா the value of heat, the SI unit of heat வந்து நம்ம joules நம்ம புரிஞ்சுக்கிறோம். Heat வந்து is a form of energy. It's an energy which keeps objects hot, which gives the sensation of hot to objects. So அதுதான் நம்ம heat ன்னு சொல்றோம். Okay, so it is about the energy that I'm talking. So heat can get transferred from one object to another, definitely. So ஒரு object hot இருக்கு, இன்னொரு object cool இருக்கு, நான் ரெண்டுமே நான் சேர்த்து வைக்கிறேன். அப்போ heat and the higher object and the object which is more hotter would transfer the heat from itself to the object which is cold. Is it? Yeah, so that is the main thing. இப்போ இங்க வந்து நம்ம ஆப்ஜெக்ட் ன்னு சொல்றது எதை சொல்றோம்? The bonfire தான் நம்ம ஆப்ஜெக்ட்டா வச்சுக்கிறோம். So it is basically the source of heat. So heat is getting transferred from there to the surroundings where people are sitting. So probably the palms அப்படின்னு கூட சொல்லலாம். The palm would basically absorb the heat. So in the situation நம்ம பொறுத்த வரையிலுமே, so heat is getting transferred from the wood or the bonfire to the people sitting around it. So it is getting transferred. It is a form of energy. But when you say temperature, it is a different. It has a different meaning. Temperature அப்படிங்கும்போது, so it is basically the measurement of heat. How hot it is. நம்ம எப்படி புரிஞ்சுக்குவோம்? By the method of temperature. It is a degree of hotness or coldness of an object. So how hot or how cold an object is, that is your temperature. So both are different. Have their different meanings. So we'll move on. So I hope the concept of heat and temperature is clear. So now we'll move ahead and see what's there.
So we can raise our body temperature either by direct transfer of heat or by doing some mechanical work. Let's consider another example. If a burner is placed below a beaker containing ice cubes, the ice cubes will melt. Alternatively, the ice cubes will also melt if they are rubbed against each other. This means that both heat and work can cause a change in temperature or a change in the state of a body.
Okay, so very very important. இங்க வந்து ஒரு ரெண்டு important terms வந்து introduce பண்றாங்க, both work and heat. So work அப்படிங்கிறது வந்து but they go hand in hand. Now when do we say work is done? So work is said to be done when you apply heat and you try to change the state of motion of a body. So generally in physics when you talk about work, அதுதான் work. So இங்க வந்து பாத்தீங்கன்னா, so we are the ரெண்டு situations கொடுத்திருக்காங்க. Right side பாத்தீங்கன்னா they have given situation where ice cubes எடுத்திருக்காங்க, கையில வச்சிட்டு rub பண்றாங்க. So rub பண்ணும்போது என்ன நடக்குதுங்க? There is a friction which is produced, and the friction நால there is a heat energy which is there. So transferred from the palms to the ice cubes. அதனால ice cubes வந்து they tend to move against each other, and therefore from solid state அது liquid state மாறுது. So you can see that there is a change in state from solid to liquid. அந்த ஒரு transition நம்ம பார்க்கிறோம். Same way, the first case left side diagramல பாத்தீங்கன்னா ஒரு conical flaskல தண்ணி வந்து ஊத்தி they have kept in on top of a Bunsen burner. அது heat பண்ணும்போது what's happening there? The liquid water at liquid state would eventually get vaporized provided boiling point is met. So boiling point reach பண்ணும்போது எல்லாருக்குமே தெரியும் தண்ணியோட boiling point வந்து is 100 degrees Celsius. So when it reaches 100, obviously it would get converted to vapor, water vapor or superheated steam அப்படின்னு சொல்றோம். So don't you think there is a change in state of the body? Yes, there is a change in state which is so heat and work are both important to cause a change in temperature or the change in state of the body. So temperature also changes as well as the state of matter also typically can change. These are two important aspects that we need to keep in mind. So and important concepts வந்து நம்ம மைண்ட்ல வெச்சுக்கணும். So this is an important thing which needs to be known. So we'll move ahead.
The English physicist Dr. Joule performed many experiments to study the relationship between heat and work done. He concluded that 4,180 joules of work is equivalent to 1 kilocalorie of heat.
Okay, இங்க வந்து
Did you
வந்து ஒரு ரிலேஷன்ஷிப் கொடுத்திருக்காங்க. So what is the joules to kilocalorie? Kilocalorie na KCAL அப்படின்னு சொல்றோம். இது வந்து நீங்க பெரும்பாலுமே இந்த டேர்ம்ஸை வந்து நீங்க ஃபுட் பேக்கெட்ஸ் பின்னாடிலாம் பார்த்துருப்பீங்க, எஸ்பெஷலி சூப்பர் மார்க்கெட்ஸ்ல. whenever you buy any food packet, நீங்க வந்து இந்த நியூட்ரிட்டிவ் கண்டென்ட், நியூட்ரிஷன் கண்டென்ட் அப்படின்னு சொல்லி ஒரு டேபிள் போட்டிருப்பாங்க. கார்ன்ஃபிளேக்ஸா இருக்கட்டும், சாக்கோஸா இருக்கட்டும், இல்ல எனி பர்டிகுலர் packaged food item that you buy, they give you the nutrient value. So அங்க பாத்தீங்கன்னா கிலோ கேலரிஸ் அப்படின்னு சொல்லி மென்ஷன் பண்ணிருப்பாங்க. 5 kcal, 0.5 இல்லைன்னா 10, 15 அந்த மாதிரி கொடுத்துருப்பாங்க. So that is basically the amount of energy that we are getting from that corresponding food packet. So something to do with it. So that is the meaning. So here we'll see what concept it has here.
Ever notice that when a thermos flask containing tea is shaken vigorously, the temperature of the tea increases?
Yes, இது வந்து ஒரு சிச்சுவேஷன் கொடுத்திருக்காங்க. தெர்மோ ஃப்ளாஸ்க்ல வந்து நீங்க சூடான ஐட்டம்ஸ் வந்து நம்ம லாங் பீரியட் ஆஃப் டைம்க்கு வந்து அது சூடா தக்க வச்சுக்கணும் அப்படிங்கிறதுக்காக we use thermos flask, இல்லைன்னா தெர்மோ ஃப்ளாஸ்க் யூஸ் பண்ணுவோம். இப்போ தெர்மோ ஃப்ளாஸ்க்ல நீங்க ஹாட் ஆப்ஜெக்ட்ஸ், ஹாட் சப்ஸ்டன்சஸ் ஊத்தி, லிக்விட்ஸ் ஊத்தி நீங்க அதை ஷேக் பண்ணீங்க அப்படின்னா how come the heat increases or temperature increases? Why? Who can tell me the reason? எதனால வந்து இன்க்ரீஸ் ஆகுது?
சார் ஒர்க் டன் நடக்குது.
ஒர்க் டன் நடக்குது. இன்னும் நம்ம வந்து இன்னும் அந்த கான்செப்ட் எல்லாம் போகல தம்பி. நம்ம we'll see some give me a simple answer. Work done வந்து நம்ம இன்னும் பார்க்கவே இல்லை.
Because of friction inside the molecules.
The thermoflask insulate
ஷேக் பண்றனால அது ஹீட் ப்ரொடியூஸ்
ஷேக் பண்றனால ஹீட் பண்ணுது. எஸ், ஆனா ஏன் அதுதான் क्वेश्चन. ஷேக் பண்ணும்போது ஹீட் ப்ரொடியூஸ் ஆகுது டெஃபினட்டா, அதை நான் புரிஞ்சுக்கிறேன். பட் எதனால?
there is no way to transfer of heat.
Correct. Transfer of heat வந்து the heat cannot escape out. அது true because it is an isolated system. ஆமா, வெளியில வராது ஹீட். அது வந்து ஒரு ஓகே ஒரு ரீசனா வெச்சுக்கலாம். பட் அது பிரைம் ரீசன் கிடையாது. Anybody else? It's correct. You good that you guys are trying. One more. I think somebody said friction if I'm not wrong. யார் அது? Was it Prasanna?
Yes sir.
Okay. Friction is correct. The water molecules or the liquid substance present inside the flask would rub against each other due to friction. So due to friction, obviously there is going to be a slight increase in temperature. Not considerably very high, but very slight change in temperature, or a slight increase the solution. That is because of friction, purely because of friction. Okay. Obviously work also comes into picture, but we will look at that in a later stage. But primary reason would be friction. Yeah. Okay, so moving on.
Surprised? Let's understand this with the help of the first law of thermodynamics. We know that any bulk system consists of a large number of molecules. The internal energy U of a system is the sum of the potential and kinetic energies of the molecules of the system in a frame of reference relative to which the center of mass of the system is at rest. Now let's understand the first law of thermodynamics, which states that the amount of heat Q transferred to a system is partly used to increase the internal energy of the system, and the rest is used in doing work on the surroundings.
Okay. So இங்க என்ன சொல்றாங்க அப்படின்னா they are talking about a system, a particular system. So when you take இங்க வந்து நம்ம system அப்படின்னு சொல்றது எதை சொல்றோம்? இந்த piston, இங்க ஒரு piston கொடுத்திருக்காங்க. கீழ வந்து you can see that heat is applied. ஓகேங்களா? So this corresponding thing, the entire piston along with the application of heat at the bottom is called a system. So இது எல்லாத்தையுமே சேர்த்து தான் நம்ம ஒரு system அப்படின்னு சொல்றோம். ஓகே, இப்போ பிஸ்டன்ஸ் எல்லாம் பார்த்தீங்கன்னா பெரும்பாலுமே they are used to do work. இப்போ ஹைட்ராலிக்ஸா இருக்கலாம். ஹைட்ராலிக் பிஸ்டன்ல வந்து typically fluid உள்ள ஃபில் பண்ணிருப்பாங்க. There are air pistons also where air is filled inside. Air வந்து expand ஆகும். expand ஆறதுனால piston வந்து மேலேயோ இல்ல கீழேயோ it will move. So that is what is the general idea. இப்போ when I apply heat to the system அப்படிங்கிறது நான் வந்து இங்க ஹீட் அப்ளை பண்றேன் இந்த piston கீழ இந்த பேஸ்ல வந்து when I apply heat, நம்ம எல்லாருக்குமே தெரியும் the piston குள்ள there is no liquid, there is gas. So gas வந்து has got a property of expansion. gases can expand அப்படின்னா when you supply heat to the gas obviously the gas expands. இப்போ real life examples நீங்க பாத்தீங்க அப்படின்னா you can talk about இந்த helium balloon எல்லாம் பார்த்திருக்கீங்களா? So they all flow up, they all go up. So helium is very very lighter, so it typically tends to go up. Same way hot air balloonsல வந்து it is air only that is filled, but still நீங்க பாத்தீங்கன்னா உள்ள வந்து there is a ஒரு flame, ஒரு தீப்பந்தம் மாதிரி ஒன்று எரியும். So because of that the hot air balloon travels up. So basically by providing heat you are increasing the internal energy of the system. Now internal energy na ennadu? It is the sum of both potential and kinetic energy. So rendume when you try to sum up you talk about the internal energy of any system. Adha nama internal energy appdi solluvom. Seriyala, this is something important to remember. So when I say about internal energy, it is the summation of both the potential energy and kinetic energy of that system. So இங்க நான் potential energy அப்படின்னு சொல்றது எதை சொல்றேன்? Initially piston வந்து கீழே இருந்தது. So when I supplied heat, the air molecules inside this piston, so typically what happened, they started moving with a greater kinetic energy. Initially they were at a lesser temperature. When I supplied heat, they started moving randomly in all directions. They started expanding. So due to expansion, thermal expansion nadadadunala, you can see that the piston started moving up. They started occupying a greater volume or a greater space. So adanal the piston is moving. Now piston mela move aradunala, don't you think work is also done? Yena there is force applied upwards and the piston has moved from one position to another. So adanal you say that work is also done. Ipo work done அப்படினு பார்த்தோம்னா physicsல work done is the product of force and displacement. நீங்க ஏற்கனவே படிச்சிருப்பீங்க grade 9 இல்ல 10th you would have learned. So that is why we say work is also done. So அதனால whenever you talk about first law of thermodynamics, you see there are two important quantities. First thing is there is work involved plus there is change in energy or change in internal energy also, that is. So according to first law, whenever you supply heat to a system, the heat is used up to change the internal energy of the system and the system also helps to do work. So adanaliye nama heat வந்து நம்ம எப்படி எழுதலாம்? Heat can be written as the summation of change in internal energy delta U plus work done by the system W. So that is the idea. So புரிஞ்சுதுங்களா? That is the first law of thermodynamics. Okay, is it clear based on the explanation? So we'll see the animation also, but that is the big picture. Okay, so we'll see.
The first law of thermodynamics can also be written as shown. If heat energy is transferred into the system, Q is positive. If heat energy is transferred out of the system, Q is negative.
So இங்க வந்து there are two important aspects. So heat energy வந்து நீங்க சிஸ்டத்துக்கு ப்ரொவைட் பண்றீங்க அப்படின்னா நம்ம அதை பாசிட்டிவா எடுத்துக்கணும். சப்போஸ் சிஸ்டம்ல இருந்து அந்த ஹீட் வெளியேறுது அப்படின்னா நம்ம Q வந்து நெகட்டிவா எடுத்துக்கணும். So these are two important aspects about the heat based on whether system is giving you heat or the system is absorbing heat and doing work. So அத பொறுத்து நம்ம அதோட சைன் வந்து நம்ம சேஞ்ச் பண்ணணும். These are the two important aspects for heat.
When work is done by the system, W is positive. When work is done on the system by the surroundings, W is negative.
அதே மாதிரி work done கூட சொல்றாங்க. எங்க நெகட்டிவ் and எங்க வந்து it will be positive. When work is done on the system and when work is done by the system. சரிங்களா? So accordingly you are going to apply the sign convention where it is positive and where it is negative. So அதே மாதிரி தான் நம்ம ஹீட்டுக்கு நம்ம எப்படி சொல்லியிருந்தோமோ same thing would apply for work also. Okay, so these are important aspects that you should know. So we'll move on.
When the thermos flask is shaken vigorously, work is done on the system, hence W is negative. The tea in the thermos flask is insulated from its surroundings. Hence, no heat energy is transferred to the thermos flask and thus Q equals 0. So, this means change in internal energy is positive.
So change in internal energy வந்து நம்ம அந்த ஒரு எக்ஸாம்பிளுக்கு வந்து நம்ம பாசிட்டிவ் அப்படின்னு சொல்றோம். ஏன்னா completely it is used up for doing work. So அதனால தான். So heat is not getting escaped anywhere. So அதனால that term becomes zero and completely change in internal energy would be equal to the work done on the system. That is on the flask, thermos flask, by the person who is shaking the flask. So அதுதான். சரி, so we'll go ahead.
Positive delta U means the final internal energy of the tea is greater than the initial internal energy. Since temperature is proportional to the internal energy of a system, increase in the internal energy of the tea implies increase in the temperature of the tea in the thermos flask.
சரிங்களா? So that is the idea. So when you shake the thermos flask greaterly, what happens? There is change in temperature. We do understand due to friction that there is going to be an increase in temperature. So temperature அதிகமாகும். So அதனால என்னன்னு சொல்றோம், internal energy வந்து is getting increased. So therefore the temperature is also getting increased. So totally it is being used for doing work. So because you are doing work on the system, there is an increase in temperature. That is because of the change in internal energy. And heat, is heat getting transferred here? No, heat is not getting transferred. Why it's not getting transferred? Yeah, it is completely isolated thermos flask, insulated air. You cannot, the heat is not going to escape out. It will be inside itself. So it is not going to come out. Well, that is the idea. So we'll move on.
Now let's recapitulate what you have just learned in this animation.
So this is a summary of summary by. Okay, so this is all about the first law of thermodynamics. So we have seen this. So we move on to the next module. So நம்ம வந்து இத 3D versionல பார்க்கலாம் திரும்பியுமே for a better understanding. And okay, அதுக்கு முன்னாடி ஒரு சின்ன ஒரு activity based on the understanding and then we'll go to the other parts. So இதுக்கு எனக்கு சொல்லுங்க, where there is a chemical energy getting converted to light and heat energy. So the first one வந்து bulb கொடுத்திருக்காங்க, second pictureல வந்து you have a plant growing, third வந்து you're heating a vessel. So where should I drop the first one? Here
Chemical energy to light energy, sir.
Chemical energy to light and heat energy, sir.
Chemical energy to light and heat energy. அதாவது bulb சொல்றீங்களா?
Yes, sir.
Excellent.
Okay, good. Second one.
Light energy to chemical energy.
energy.
Excellent.
Yes, perfect. Third one.
Light, the heat.
To light and heat energy, sir.
Chemical energy.
Yeah, to light and heat energy according to say. This is a small activity. Okay, so that's it with this module. Go to the next one. So அடுத்தது வந்து நம்ம செகண்ட் பிளாக் போலாம்.
The second law of thermodynamics. The second law of thermodynamics states that the natural processes are spontaneous and lead to disorder or entropy of an isolated system will increase over time. The law also states that the changes in the entropy will not be negative. Before we understand the second law of thermodynamics, let's understand a related term, entropy. Entropy describes the degree of freedom or randomness or disorder in a system. Let's explain this concept.
ஓகே, ஸோ நம்ம ஃபர்தர் நம்ம பார்க்கறதுக்கு முன்னாடி நம்ம வந்து சில இம்பார்ட்டன்ட் டேர்ம்ஸ் வந்து ஃபர்ஸ்ட் புரிஞ்சுக்கணும். இந்த லா வந்து புரிஞ்சுக்கிறதுக்கு என்ட்ரோபி அப்படிங்கிறது என்ன? டிபிக்கலி கெமிஸ்ட்ரியில வந்து என்தால்பி அப்படின்னு ஒன்று படிச்சிருப்பீங்க. ஸோ இஸ் போத் சேம் என்ட்ரோபி அண்ட் என்தால்பி ஆர் தே சேம் ஆர் தே டிஃப்ரெண்ட்? என்ன ஒரு சென்ஸ்ல இஃப் இட் இஸ் சேம் ஆர் இட் இஸ் டிஃப்ரெண்ட் அப்படின்னு சொல்வீங்க?
Different.
They are different. Okay, how is it different? Entropy
Enthalpy internal energy, entropy randomness, degree of randomness.
Degree of randomness. Okay, so degree of randomness இல்லனா disorderliness னு சொல்றோமே, அது என்னது? What is degree of randomness?
Proper alignment.
Proper alignment. Okay, சரி. இன்னும் ஒரு சிம்பிள் டேர்ம்ல சொல்ல முடியுமா? What is entropy?
Disorder-ஆ இருக்கிறது.
Disorder-ஆ இருக்கிறது. Okay, so ஒரு எக்ஸாம்பிள், ஒரு ரியல் லைஃப் எக்ஸாம்பிள் ஃபார் entropy. இது வந்து has a higher entropy and that has a lower entropy அப்படின்னு சொல்ல முடியுமா? Using any example. இப்போ நீங்க வாட்டரே எடுத்துக்கலாம் as a study. You try to investigate the degree of the orderness or disorderness, whatever you may call it. So அத வந்து நம்ம வாட்டருக்கு வந்து அப்ளை பண்ணுவோம். So what happens when you take water? நம்ம எல்லாருக்குமே தெரியும் water can exist in 3 different states of matter இல்லையா? We have triple point for water. Water can exist as solid state, liquid state and also gaseous state. Solidல இருந்துச்சுன்னா நம்ம ஐஸ்னு சொல்றோம், liquid இருந்துச்சுன்னா நார்மல் வாட்டர் தண்ணியா இருக்குன்னு சொல்றோம். And if it is going to be heated to a very high temperature, probably beyond the boiling point, அப்போ வந்து gaseous state ல இருக்கு அப்படின்னு சொல்றோம். இப்போ இந்த 3 ஸ்டேட் ஆஃப் மேட்டரை வந்து நீங்க அனலைஸ் பண்ணி சொல்லுங்க, எதுக்கு வந்து என்ட்ரோபி ஹையரா இருக்கும், எதுக்கு வந்து என்ட்ரோபி கம்மியா இருக்கும்? where there is a higher
வாட்டர் வேப்பருக்கு என்ட்ரோபி அதிகம் சார், சாலிட் ஐஸ்க்கு வந்து என்ட்ரோபி கம்மி.
Perfect. ஏன்னா solid ice அப்படின்னா the ice is not the property where you can see that the molecules will not move. They have frozen. So iceல வந்து you have all the molecules or atoms or whatever it might be, they are not moving. So they are in a particular order, they are in a lattice. So அதனால they don't move. So நம்ம அங்க வந்து ஆர்டர் இருக்கா? Yes, there is an order, but is it random? No, there is no randomness because they are not here and there, they don't move here and there. So அதனால நம்ம வந்து we say entropy is least for ice. அதுவே நம்ம வந்து gaseous state ரெஃபர் பண்ணும்போது the atoms or molecules, they are randomly moving in all directions. Yeah, so we say that there is a greater entropy. So entropy has something to do with the orderness of a system. The disorderliness தான் நம்ம வந்து we talk about, we say it is entropy. ஆர்டரா இருந்துச்சுன்னா நம்ம entropy பத்தி பேசவே வேண்டாம். There is no entropy is zero அப்படின்னு சொல்லி போயிட்டே இருக்கலாம். But if there is a disorderness, in that case we say that there is an entropy. So அதுதான் ஒரு crisp idea about entropy. So I hope உங்களுக்கு entropy வந்து clear-ஆ இருக்குன்னு நம்புறேன். So having understood the term, we'll proceed further.
If we leave an ice cube on a plate at room temperature, it begins to melt. If we observe the molecular arrangement in the ice block, we can see all the molecules arranged closely in an orderly fashion. This orderly.
Okay, sir. எனக்கு இன்னொரு இதோ கூட சொல்லுங்க. இப்போ நான் உங்களுக்கு ஒரு எக்ஸாம்பிள் கொடுத்தேன். Ice, we just talk about water in 3 different states of matter. So entropy வந்து நம்ம எப்படி எல்லாம் இன்க்ரீஸ் பண்ணலாம்? இப்போ ஐஸ் கியூபை நம்ம எடுத்து ஃப்ரீசர்ல இருந்து எடுத்து நம்ம வெளியில வச்சோம்னா will entropy increase or will it decrease?
Increases.
It will increase. That means temperature from the surroundings, the ice is going to absorb the temperature. ஏன்னா ஐஸ் வந்து temperature is less. வெளியில இருக்கக்கூடிய சரௌண்டிங் ஒரு டெம்பரேச்சர் அதிகமா இருக்கு. ரூம் டெம்பரேச்சர் வந்து கிரேட்டர் இல்லையா ஐஸ் விட? அதனால so temperature from the surroundings is going, there is a transfer of heat from surroundings, the heat is getting transferred to ice. அதனால ice is going to melt and eventually what happens, it will flow and it is going to increase its entropy. அதோட randomness வந்து increase ஆகும். அதனால we say that entropy increases proportionally with temperature. So as you increase temperature, so does the entropy. Okay, so that is the first and foremost concept that you should. சரி, so we'll proceed further.
Cleanliness in the isolated system will spontaneously lead to disorder, or what we call entropy. It means the molecules will slowly begin to move away and cause the ice to melt. The second law of thermodynamics also states that the entropy will increase over time. In our example of melting ice cube, the disorderliness of molecules will increase over time. The law states that the changes in entropy will not be negative. In our melting ice block, ice will melt into water, but water will not solidify into ice naturally. In other words, the disrupted molecules will not get back to orderliness by themselves. When a hot block of iron is in contact with a normal block of iron, the heat will flow from hot block to the cold block, but not in the opposite direction spontaneously. A ball will roll down a slope but will not roll up spontaneously without external assistance. Summary. The second law of thermodynamics states that the natural processes are spontaneous and lead to disorder, or entropy of an isolated system will increase over time. The law also states that the changes in the entropy will not be negative.
So that is what in the module நம்ம புரிஞ்சுக்கணும். இதை நம்ம பார்த்திருக்கோம். So second law of thermodynamics வந்து என்ன ஸ்டேட் பண்ணுது? It tells you that all natural processes are spontaneous in nature and they lead to disorderness or entropy of an isolated system, and they will increase over time. So this is what is the basic idea, crisp idea about second law of thermodynamics. நம்ம entropy ஓட meaning பார்த்தோம், and variation of entropy with respect to temperature. So அதையும் நம்ம பார்த்திருந்தோம். So what is all the differences we just saw with a small case of water into three different states of matter, that is solid, liquid and gas. So we'll move on, and the law also states that their change in entropy will not be negative. So that means in the opposite direction நடக்காது. ஐஸ் எடுத்து நம்ம வெளியில வச்சோம்னா அது தண்ணியா வந்து நேச்சுரலாவே ஆகும், பட் திரும்பியுமே it will not become ice until and unless you are going to freeze it. அது வந்து it will not take place. The opposite will not take place. So அதுதான் வந்து சொல்ல வர்றாங்க. So we'll move on. So இங்க வந்து they are asking you a small activity to track the images that represent the second law of thermodynamics. அதை வந்து நம்ம டேபிள்ல வந்து ட்ராக் பண்ணணும். எது வந்து செகண்ட் law வந்து டிபிக்ட் பண்ணுது அப்படின்னு சொல்லி. So 4 இமேजेस கொடுத்திருக்காங்க. So tell me the first image, does it depict second law of thermodynamics?
Yes, sir.
Yes, sir. Excellent.
Second
Yes,
one?
No, sir.
No. Third one?
Yes, sir.
Yes.
Excellent.
Hot object it goes to the cold object. Correct. So this is what is depicting the second law of thermodynamics. Good. That's it. So we'll go on to the next module. So once we finish, then we'll see all the questions which are possible. Now இப்போ வந்து நம்ம அடுத்த we are almost coming to an end. So last part we are seeing heat engines, the heat pumps and refrigerators. So இத பார்க்கலாம்.
Heat engines, heat pumps and refrigerators. Petrol prices are rising by the day. In such a scenario, people have begun to switch over to fuel-efficient vehicles. But how are fuel-efficient vehicles produced? You guessed right, by improving the efficiency of their heat engines. Through this and
So fuel efficiency அப்படின்னு நம்ம சொல்றது எதை சொல்றோம்? What do you mean by fuel efficiency here? Anybody? எப்போ வந்து நம்ம fuel வந்து efficient சொல்றோம், இல்லனா ஒரு engine வந்து efficient சொல்றோம்? Yes.
Heat is converted into work.
Heat is converted to work. Yes. ஆனா வந்து நம்ம completely whatever heat you are producing, is it getting converted to work?
sir.
Huh?
Not
No, sir.
Not really. We don't have something called as an ideal machine. So ideality வந்து இந்த உலகத்துல கிடையவே கிடையாது. பட் அந்த அது வந்து நம்ம ஒரு ரெஃபரன்ஸை வச்சு தான் we are trying to talk about others. So ஒரு engine வந்து cannot be 100% efficient. It is not possible at all. You don't have any engine on this planet which is 100% efficient. அப்படின்னா நம்ம கொடுக்குற எனர்ஜி வந்து அப்படியே அது வந்து work கன்வெர்ட் பண்ணுமா அப்படின்னா பண்ணாது. So there is some loss of heat. Heat வந்து எப்படியோ உங்களுக்கு loss ஆகியே ஆகும். There is going to be a loss. Even though you try to build a system, it can be more efficient but cannot be 100% efficient. So that is the main idea. For example, நீங்க நம்ம வண்டி ஓட்டிட்டு போறோம். ஸோ நீங்க பாத்தீங்கன்னா ஆஃப்டர் ஒரு லாங் டிரைவ் நம்ம போறோம்னு வச்சுக்கோங்களேன். ஸோ 1 hour இல்லைன்னா 1.5 hours. ஸோ நீங்க அப்புறம் if you just touch the vehicle front portion நீங்க டச் பண்ணீங்க அப்படின்னா you can see that there is a heat loss. So ஹீட்டை வந்து நம்ம உணர்றோம் இல்லையா? The radiator வந்து you obviously have water filled in it. So which helps you know the car to radiate away the heat. So there is a coolant. நம்ம எல்லாமே அந்த ஒரு சிஸ்டம் வந்து எல்லா வெஹிக்கிள்ஸ்மே இருக்கு. So that means whatever your fuel you're providing to the vehicle, that completely it is doing work. Not necessarily. There is some loss of heat. So that is why we say the engines that we are using are not 100% efficient. If it is 100% efficient, then you call that as an ideal engine. Everybody would go and purchase it. But it is not possible. So it can be more efficient. நம்ம வந்து கன்ஸ்ட்ரக்ட் பண்ண முடியுமே ஒழிய 100% efficiency cannot be achieved. Okay, so that is what is the typical idea, because there will be some way where the heat is typically lost. That is basically the whole idea of this concept. So we'll move on.
Elimination, let's learn more about heat engines and other devices that work on the same principle. A heat engine is a device that is used to convert heat to work by allowing a system to undergo a cyclic process.
Okay, so this is the basic definition of a heat engine. So in the picture, they are showing you an engine. So it's a device. So in the device, the heat it is converting to work. So heat obviously combustion of fuel. So நீங்க இப்போ cars automobiles எடுத்துக்கிட்டீங்க அப்படின்னா so பெரும்பாலுமே whatever fuel நீங்க கொடுக்குறீங்க, இப்போ கேஸா இருக்கலாம், CNG, or it can be petrol, or it can be diesel. So எந்த ஒரு fuel நம்ம யூஸ் பண்ணாலுமே you have a combustion chamber. So அந்த combustionல வந்து ஒரு ignition spark create ஆச்சுன்னா immediately the fuel is being is undergoing combustion. உங்களுக்கு எல்லாருக்குமே தெரியும் நம்புறேன் what is combustion இல்லையா? So basically where the fuel is getting heated up, the fuel has been burnt. So அதுதான் நம்ம வந்து combustion அப்படின்னு சொல்றோம். So when fuel undergoes combustion, a large amount of heat is produced. So அது வந்து என்ன பண்ணும்னா உள்ள வந்து pistons இருக்கும். அந்த pistons வந்து it will push. So as the pistons move past each other, so they will help for the vehicle to move. So அப்படிதான் வந்து vehicles are move. That is how the heat engine works typically. So அது வந்து மூவ் ஆகும்போது obviously work is being done. So it is a cyclic process. அதாவது it will repeat again and again. சரிங்களா? So that is what is corresponding heat engine. இப்போ நம்ம geared vehicles எடுத்துக்கிறோம்னு வெச்சுக்கோங்களேன். So when you talk about car, so typically when you first gear நீங்க போகும்போது ஸ்லோவா போகும். You increase the gear second, third, fourth அப்படி நீங்க போகும்போது, especially on a highway. So அப்போ பாத்தீங்கன்னா you will have a greater force with which the vehicle is moving forward. So you have a greater RPM அப்படின்னு சொல்லுவாங்க, rotations or revolutions per minute. So அது ஏன்னா the fuel will be combusted more, a greater combustion of the fuel. Greater the combustion, greater the amount of heat produced. Greater the heat, greater the pistons are going to move to rotate your wheels. So typically இப்போ பாத்தீங்கன்னா vehiclesல நமக்கு we have two different categories. உங்களுக்கு SUVs இருக்கு, LVs இருக்கு. இந்த மாதிரி you have different categories. So usually rear wheels தான் power wheels னு சொல்லுவோம். High end vehicles எல்லாம் எடுத்துக்கிட்டீங்கன்னா all four wheels will be powered. So அங்க வந்து you will have both the front and back shafts as driving shaft. So அங்க வந்து you will have a greater amount of power for that vehicle. So that depends on the model of the vehicle. So அப்போ பாத்தீங்கன்னா greater amount of heat is still required. So it will be even more powerful when you talk about such vehicles. So the heat engine has to be more and more efficient to run such vehicles, giving you a double power. I mean front shaft and rear shaft ரெண்டுமே power shaft இருக்கணும் அப்படின்னா So you have a greater amount of heat that needs to be supplied. So you need a better engine, to be constructed. So on the case level, that is what we try to understand. So typically, heat engine is something which converts your heat profitably into work. So if you convert pandichina, you call it a heat engine. Ipo and the full 100% நீங்க supply பண்ற heat may work ஆகுதா? Definitely no. Some parts of your machine also will get heated up. இப்போ engine பாத்தீங்கன்னா is made up of metal தானே, நம்ம plastic வந்து யூஸ் பண்ண மாட்டோம் typically. ஏன்னா at high temperatures plastic வந்து உருகிடும். So certain areas might be thermo-setting plastic, but that's a different story. But typically it is metallic matte finish that they give. So the metal வந்து is a good absorber of heat, நம்ம எல்லாருக்குமே தெரியும். So fuel combustion ஆகும்போது உள்ளது வந்து நீங்க என்னதான் அந்த சேம்பரை வந்து ஐசோலேட்டடா வச்சாலுமே still there is some loss of heat that is taking place. So அதனால we say all heat engines are not completely efficient or everything is not converted to work. That is the idea. Okay, so we'll move on.
For example, a petrol engine generates heat by burning petrol. A part of this heat is used in driving pistons that eventually moves the vehicle. Some of the heat is dumped out of the vehicle through the exhaust pipe.
So புரிஞ்சுதுங்களா? So in the heat வந்து நம்ம supply பண்றது எல்லாமே is made to work, not necessarily. Some of it is used to drive the piston, some of them is used for as basically the exhaust, vehicular exhaust which comes out, silencer and சொல்றோம் இல்லையா? So it comes out. அந்த மாதிரி there are different vents where this heat is going to escape out of the system. So therefore it's not 100% efficient.
In a cyclic process, the initial and the final states of the system are the same. So there is no change in the internal energy of the system.
ஆமா. So இது வந்து ஒரு important point that needs to be kept in mind. எப்பவுமே நம்ம ஒரு சிஸ்டம் வந்து cyclic system அப்படின்னு சொல்றோமோ, in that case the change in energy or the change in internal energy of that system is zero. ஏன்னா it comes back to its original state இல்லையா? So அதனால it will cancel out, எல்லாமே cancel out ஆகி it is going to become zero. Always remember, for systems which are cyclic, so the change in internal energy is zero. இப்போ can you give me examples of cyclic systems? Or what is cyclic system in reality? Yes? Anybody? So எதுக்கு நம்ம cyclic system அப்படின்னு சொல்றோம் in this case? சொல்லுங்க.
Sir, refrigerator.
Now the okay, example is okay, that is okay. Why do we call the system as cyclic? இல்லனா cyclic process அப்படின்னு சொல்றோமே, எதுனால? Why?
Sir, work is done in a system cyclically, sir.
Work is done cyclic? No. When work is done, equal amount of it is being converted to heat in the system, and it returns back to its original state from where it started. If it returns back, then you call it a cyclic system or a cyclic process. So cyclic process is something when a system is returning back to its original state of thermodynamics, then you call it a cyclic system. For example, the heat engines which we use in vehicles are cyclic systems. They come back to their original state. So that is a cyclic system. For the MR, you talk about refrigerator. Yes, of course, they also come back to their original state. So then you say that they are a cyclic process or a cyclic system. So we'll see. Proceed further.
A heat engine basically consists of a working substance, a hot reservoir, and a cold reservoir.
So இதுதான் வந்து different classifications of a heat engine. Heat engine வந்து ஒரு 3 categories நம்ம classify பண்ணலாம். First வந்து working substance, ரெண்டாவது வந்து hot reservoir, and மூணாவது வந்து ஒரு cold engine அப்படின்னு சொல்றாங்க. So what is meant by working substance? இங்க especially in the context of heat engine, working substance na என்னது அப்படின்னு we'll see. Anybody knows what is a working substance? Anyways, I'm going to explain, but still, you have an idea about working substance?
The system,
Sir,
Perfect. Fuel. Somebody said fuel. That's right. So working substance is something such as, it is a fluid as the fuel in solana. Obviously, fuels can be in liquid state or gaseous state. CNG the gaseous state. Petrol, diesel liquid state. If you talk about wax, that is in solid state. So it depends on the nature of fuel I am talking about. So that is a working substance. So is it helping in changing the thermodynamic system? It is helping in doing work. Yes. So other than a working substance, that is very, very important. Always for a heat engine, working substance is the prime important area. Without a working substance, you cannot change the thermodynamic process. You cannot initiate a thermodynamic process. So that is very important. Working substance is important. That is the driving force. So oil or petrol, diesel, any fuel. So that is your working substance. Sorry. Next one, the hot reservoir. Hot reservoir, now what is it in the heat engine or thermodynamics lab? Hot
Temperature.
Okay. The temperature it is changing.
Sir, heat produced.
Stored for high temperature.
Okay. So hot reservoir அப்படினா in the heat engine for example நாம ஒரு ஆட்டோமொபைலோட engine எடுத்துக்கலாம். அங்க பாத்தீங்கன்னா ஒரு engine இருக்கு. உள்ள ஒரு engine இருக்கு, heat engine இருக்கு. hot reservoir அப்படிங்கிறது அந்த எங்க அந்த fuel burn ஆகுதோ, எங்க அந்த fuel combustion ஆகுதோ, so on the area we talk about it as a hot reservoir. So that is a hot reservoir where the fuel is being burned. That is going to produce a heat. So that is called the hot reservoir where the burning chamber is present, the combustion chamber is present. So that is typically the hot reservoir. It is process of burning or combustion of your fuel inside the engine. That is the hot reservoir. That is what is the meaning of hot reservoir. Next, cold engine and சொல்றாங்க. எதுக்கு? நம்ம படிக்கிறதே heat engine தான். இங்க எது cold engine வந்துச்சு? Why do we talk about a cold engine? Actually, it's a cold reservoir. அங்க இங்க மாத்தி கொடுத்திருக்காங்க. சரி. So what is cold reservoir?
So the surrounding
Hot reservoir transfers heat to cold engine.
Okay. கோல்ட் ரிசர்வாயர் அப்படிங்கிறது என்னன்னா, இப்போ அந்த ஹீட் ப்ரொடியூஸ் ஆகுது இல்லையா உள்ள அந்த ஃபியூவல் ஹீட் ஆகும்போது, when it is being ignited or when it is undergoing combustion, that heat needs to be used somewhere. Only then you can have work done. So obviously it is being used. அது piston இருக்கலாம், it can be some metallic part of the engine or some other areas where the heat is being used. So then you call that as a cold reservoir because there is transfer of heat from the hot area to the cold area. So you call that as cold reservoir. அது environment கூட இருக்கலாம், இல்லனா surrounding கூட இருக்கலாம், because it has been absorbed by the surroundings. So that they are all examples of cold reservoir. சரிங்களா? Not about the cold engine, we just talk about the reservoir all done. So this is the basic concept. Heat engine you can classify into three different important concepts linked to it. So heat engine ku mukyama requirements are three different requirements. முக்கியமா நம்ம பேசக்கூடிய ஒரு three important concepts first one is working substance, ரெண்டாவது hot reservoir, third cold reservoir. So these are the three important aspects of the heat engine. So இப்போ நம்ம இத டீடைலா பார்க்கலாம் what is what அப்படினு.
All these together form a system. The working substance can be steam as in a steam engine or a mixture of fuel vapor and air as in a diesel engine. The working substance, a gas in this case, absorbs an amount of heat Q1 from the hot reservoir at temperature T1. The system uses this heat energy to perform an amount of work W, which is transferred to the environment via some arrangement. In this case, the gas expands and pushes the piston that transfers the mechanical energy to a wheel via a crankshaft mechanism. Then, the working substance dumps an amount of heat Q2 to the cold reservoir at temperature T2. As the gas loses heat, its volume decreases and the piston comes back to its original position.
ஸோ இங்கே வந்து நம்ம அந்த ஒர்க்கிங் மெக்கானிசமே நம்ம பார்க்குறோம். ஸோ அந்த என்ஜின்ல வந்து என்ன நடக்குது, ஹவு இஸ் தட் என்ஜின் பீங் வாட் இஸ் த டிரைவிங் ஃபோர்ஸ் ஃபார் தட் என்ஜின் அப்படிங்கிறது வி ஆர் சீயிங். அதை நம்ம ரொம்ப க்ளோஸாக அனலைஸ் பண்ணுறோம். ஸோ ஹாட் ரிசர்வாயர் வந்து இஸ் டிபிக்லி த ஏரியா நான் சொன்னேன் ஒர்க்கிங் சப்ஸ்டன்ஸோட லிங்க் ஆயிருக்கு. ஸோ வென் இட் அண்டர்கோஸ் கம்பஷன், ஸோ ஹீட் இஸ் ப்ரொடியூஸ்ட். அந்த ஹீட் வந்து இனிஷியல் ஹீட் வந்து is Q1 because temperature at that hot reservoir when fuel is being burned, அந்த fuel வந்து அந்த எரிபொருள் வந்து எரியும் போது அதோட டெம்பரேச்சர் T1, அது அந்த எரிபொருள் வந்து உண்டாக்கக்கூடிய ஹீட் தான் வந்து நம்ம Q1 அப்படின்னு சொல்றோம். அந்த ஹீட் வந்து is being transferred to your working substance correspondingly. So obviously இங்க வந்து you have your piston which is going to work and do work, which is going to do work for you. So அப்போ என்ன ஆகும், the piston is going to expand, it will move up and then it is going to drive the corresponding wheel இருக்கலாம் இல்ல ஒரு gear இருக்கலாம், it can drive anything. And திரும்பி அது கீழே எப்படி வருது, that is because some amount of heat is lost to the cold reservoir. நம்ம ஹீட் வந்து அப்படியே வச்சுக்கிட்டோம்னா அந்த பிஸ்டன் மேலேயே தான் நிற்கும். அந்த பிஸ்டன் கீழே வரணும்னா நம்ம என்ன பண்ணணும், that heat needs to be used somewhere, it needs to be given out. So that is why we have a cold reservoir set up also. அந்த ஒரு மெக்கானிசமும் உள்ள இருக்கு. So that heat is being immediately used up. So the piston comes back to its original position. That is why we say it is a closed system. The piston will go up and eventually come down. When it goes up, heat is being transferred. Heat is increased, so it goes up. When it comes down, that heat is getting decreased. So Q2 is basically the heat transfer taking place from the working substance to the cold reservoir so that the piston comes back to its original position. முன்னாடி இருந்த அதே பொசிஷன் வந்து it will come back. So அதுதான் what is happening here in the heat engine. So because this happens alternatively, this is going to produce a rotational motion. So it is converted, the heat energy is getting converted to mechanical energy. So and the mechanical energy is what driving your car forward. So இதுதான் நடக்குது உள்ள அந்த engine குள்ள. This is what is the process. திரும்பி same thing will repeat again and again. That is why you call this as a cyclic process. So புரிஞ்சுதுங்களா cyclic process எப்படி, what is the concept of cyclic process, how the heat engine works? Is it clear to all of you?
Yes, sir.
Yes,
sir.
Okay, great. So we move on.
This cyclic process continues and heat energy is converted to mechanical energy. The efficiency of the heat engine is defined as the ratio of the work done by the system W to the amount of heat absorbed by the system Q1 in one complete cycle.
So இதுதான் formula for efficiency. பாத்தீங்கன்னா it is the ratio of the work done by the system. So அந்த சிஸ்டம் வந்து என்ன ஒர்க் பண்ணுதோ ஒரு சைக்கிள்ல, so that work done divided by Q1. Q1 வந்து is the heat transferred from the hot reservoir to your system. So that is what is Q1. Okay, Q2 வந்து is the heat transfer to the sink or to the heat transfer to your cold reservoir. So where that system, the piston needs to come back to the original state. So that is what is Q2. So don't get confused. Q1 is different. Q2 is altogether different. So ரெண்டுமே have the different terminology. So efficiency அப்படிங்கிறது வந்து what work is done in one cycle for the piston divided by the heat that is transferred to the system by your working substance and your hot reservoir put together. Okay, from the hot reservoir to your working substance basically. So அதுதான் we try to understand here. சரிங்களா, that is your efficiency. So efficiency வந்து இங்க ஒரு symbol கொடுத்திருக்காங்க. That symbol is Greek alphabet eta. eta ன்னு சொல்றோம். theta கிடையாது, theta வந்து angle, இது வந்து eta, eta. Okay, so that is the symbol for efficiency. Sorry, we'll move on.
According to the first law of thermodynamics, the amount of heat transferred to the system is used to do work by the system and to bring about a change in the internal energy of the system. The net heat energy transferred to the system in one complete cycle is the difference in the amount of heat absorbed from the hot reservoir and expelled to the cold reservoir in one cycle.
Okay, so this is all about the heat. So heat, what is the change in heat now? Q1 minus Q. So the corresponding from hot reservoir to the cold reservoir, the transfer adunala. So complete heat you can write it as Q1 minus Q. So first two equations it is from the law of thermodynamics. So the total heat is basically the change in internal energy plus work done on the system. So delta U plus W. These are all the relationships that we have. So the equations which we'll be using for solving the problems. That is the main thing.
Substituting this value of Q in the equation that represents the first law of thermodynamics, we get also the change in internal energy is zero for a cyclic process.
Cyclic process change in energy zero because it comes back to its initial state. It is going to be zero. So finally equation you will be Q1 minus Q2 is equal to W.
So the equation gets further simplified as shown. So the efficiency of the heat engine can be written as shown.
Substitute simplify LCM simplify efficiency 1 minus Q2 upon Q1. So this is what is the efficiency of a heat engine, where Q1 is the heat transfer from hot reservoir to the working substance and Q2 is heat transferred to the cold reservoir from the working substance or from the system. So this is the efficiency. So we'll move on.
If no heat energy is expelled, that is, if Q2 is zero, the efficiency of the engine is 1, which means the engine is 100% efficient.
But is it possible to achieve 100% efficiency? Not really.
No, sir.
Okay, so it is not possible. That's an ideal situation. Ideal, but in reality, it's not possible. Okay. So,
however, it is practically not possible to build heat engines having unit efficiency. Heat engines can be broadly classified into two types: internal combustion engine and external combustion engine. In internal combustion engines, the fuel is burnt inside the engine. The engines used in cars are internal combustion engines. In external combustion engines, the fuel is burnt outside the engine.
Okay, so these are two categories: internal combustion engine and external combustion engine. So இப்போ இருக்கக்கூடிய vehicles எல்லாம் நம்ம யூஸ் பண்றது பாத்தீங்கன்னா எல்லாமே internal combustion engine தான். எந்த ஒரு combustionமே வெளியில நடக்கிறது கிடையாது, எல்லாமே engine குள்ள தான் நடக்குது. So that is internal combustion engine. External பாத்தீங்கன்னா it will be outside. சரிங்களா? So அது examples பாத்தீங்கன்னா steam engines and all, which were used initial stages first steam engines எல்லாம் வந்தபோது they were all external combustion engines. So இப்போ நீங்க சொல்லுங்க, when fuel is burnt outside the engine, இப்போ ரெண்டுத்திலுமே நீங்க கம்பேர் பண்ணுங்க. அதாவது internal and external combustion engine எது more efficient இருக்கும்? Which will be more efficient? Is it internal or external? Yes. Internal தான் efficient இருக்கும். ஏன்? Why internal is more efficient?
Environmental factors affect பண்ணாது.
Yes, outside surrounding heat transfer நடக்கும், but அந்த அளவுக்கு நடக்காது as in external combustion engine. So அதனால internal combustion engines would be more efficient because என்ன நம்ம heat produce பண்றோமோ internally, it can be used for doing work rather than external combustion engine that only part of that heat is used, but most of the heat is getting dissipated out. There is a lot of heat loss அப்படின்னு சொல்றோம். So அதனால internal combustion engines are more efficient than external combustion engine. So that is the prime idea. So we'll move on.
Steam engine is an example of external combustion engine. A refrigerator is a device that has the same basic components as that of a heat engine, but its working is just the reverse of that of a heat engine. In a refrigerator, the working material absorbs heat Q2 from the cold reservoir at temperature T2. Some external work is done on the working material and amount of heat Q1 is released to the hot reservoir at temperature T1. This cycle continues and causes cooling within the cold reservoir.
So refrigeratorல பாத்தீங்கன்னா heat engineோட opposite process நடக்குது. இங்க வந்து Q1 வந்து is and Q2 பாத்தீங்கன்னா they have a different meaning. So cold reservoir வந்து is basically you can see that there is a transfer of heat happening towards working substance. So arrow marks வந்து reverse ஆகுது. That is the basic difference. ஏன்னா you can see that cold reservoir to the working substance there is a transfer of heat of Q2. And working substance there is a transfer of heat Q1 taking place to the hot reservoir. இப்போ நீங்க ஃப்ரிட்ஜ் பின்னாடி எல்லாம் போய் பாத்தீங்க அப்படின்னா இப்போ டிபிக்கலி கோத்ரேஜ் இந்த மாதிரி ஃப்ரிட்ஜ் கம்பெனிஸ்ல எல்லாம் பின்னாடி ஒரு காயில் மாதிரி வச்சிருக்காங்க. எத்தனை பேர் கவனிச்சிருக்கீங்கன்னு தெரியல. ஸோ தேர் இஸ் ஒரு என்ன சொல்றது தேர் இஸ் அ காயில் விச் வைண்ட்ஸ் லைக் ஒரு ஸ்னேக் மாதிரி தே வில் வைண்ட் இட் அண்ட் தே வில் புட் இட். ஸோ அந்த ஒரு வைண்டிங் இருக்கும். ஸோ அது வந்து ரெஃப்ரிஜரேட்டர் ஆன் ஆகி இருக்கும் இல்லையா. ஸோ இட்ஸ் ஆன் ஃபார் லார்ஜர் பீரியட் ஆஃப் டைம் அது ஸ்லோவா இட் கெட்ஸ் ஹீட்டட் அப். நீங்க வந்து டச் பண்ணீங்கன்னா you can observe it or just go close to it, you can see that it gets heated up. That is your hot reservoir. Cold reservoir is something which is inside. நம்ம ஃபுட் எல்லாம் உள்ள வைக்கிறோம். வெளியில இருந்து இருக்கிற ஃபுட் நம்ம உள்ள வைக்கும் போது வெளியில இருக்கக்கூடிய ஃபுட் எல்லாமே நார்மல் டெம்பரேச்சர்ல இருக்கும், ரூம் டெம்பரேச்சர்ல. ஆனா ஃப்ரிட்ஜுக்குள்ள டெம்பரேச்சர் கம்மியா இருக்கு. So what happens? அந்த ஃபுட்ல இருந்து whatever heat is there is getting transferred to the working substance. Working substance அப்படிங்கிறது நான் எதை சொல்றேன் ஃப்ரிட்ஜ்ல. I am talking about working substance as the coil which is there. That coil will absorb the heat. There is a compressor. உள்ள வந்து ஒரு compressor இருக்கு. That compressor is helping to compress the air inside the corresponding tube. or typical air வந்து ஒரு gas வந்து இதில் fill பண்ணிருப்பாங்க. So typically freon அப்படின்னு நினைக்கிறேன். So freon is the gas. So அதை fill பண்ணிருப்பாங்க. That immediately absorbs the heat. And heat absorb பண்ணி அது hot reservoirல வந்து dissipate ஆயிரும். அந்த coil மூலமா it gets dissipated. So that is how the refrigerator typically works. So that is the opposite process of the heat engine. So
Manish, can we close in 2 minutes?
Yes sir, yes
because
sir.
எல்லாம் 9 மணி அவங்க எல்லாம் சாப்பிட்டிருக்க மாட்டாங்க பாவம்.
Okay, சரி sir.
8:52 ஆச்சு. Maybe another 2-3 minutes. சரியா?
Yeah, another 2-3 minutes we'll wind them. Okay. That is the process.
Heat pumps and refrigerators work on the same principle, only their functions differ. The household refrigerator is used to cool a portion of space like the freezer within the refrigerator. The refrigerator is surrounded by a hot reservoir, that is, the air surrounding the refrigerator, which is at a higher temperature. On the other hand, a heat pump is used to pump heat into a portion of space like that of a room when the outside temperature is low. In simple words, an air conditioning system works as a refrigerator in summer and as a heat pump in winter. Note that both the heat pump and the refrigerator applies an external work on the working material and extracts heat Q2 from the cold reservoir and transfers heat Q1 to the hot reservoir. The coefficient of performance alpha of a refrigerator is calculated as shown. The coefficient of performance alpha of a heat pump is calculated as shown. The coefficient of performance of a refrigerator or a heat pump can be greater than 1 but cannot be infinite. Do you know why the
Okay, so this is all about the heat pump and the refrigerator. நம்ம இத பார்க்கலாம் திரும்பி in detail you will see. Okay, so I do understand that we are connected for a longer period. So we'll continue in the next lecture. So until then I'll share you the notes. So stay connected on Google Classroom. So எல்லாமே நான் post பண்றேன் and also solve the questions which are given there for practice. சரிங்களா?
Okay, thank you, Manish. We will, children, we will meet again tomorrow morning at 7:30. சரிங்களா?
Okay, sir. Thank you, sir.
Okay, sir.
Thank you.
Thank you, sir.
Bye bye. Take care.